Hi, everyone. My name is Ben Weinberg. I'm a developer advocate with the Interop Labs team. I'm here to talk about our Interchain Token Service bounty, as well as the Axelar protocol. So let's get right to it. Um, what is Axelar? Well, in its simplest, Axelar is an interoperability protocol that allows developers to send messages and assets between blockchains. It is itself a blockchain, so I kind of like to think of it as a blockchain for other blockchains. Um, the easiest way to visualize Axelar is, in my opinion, with this diagram. It operates as a hub and spoke model, which means that any of these other chains you can see here are connected to each other via Axelar or spokes talking to the Axelar hub. And the main benefit of this is that this design really works in terms of scalability. If you imagine, hopefully in the not too distant future, in a world where we have like thousands, if not someday hundreds of thousands of blockchains that want to communicate with each other, if you went more an approach of like a pairwise solution, you'd have to manually wire up each of those 100,000 chains to each of those 100,000 chains. Whereas with the hub and spoke model, all what you have to do is plug in your blockchain to the Axelar network itself, and then right out of the box, it is automatically connected to all the other chains that are also plugged into the Axelar ecosystem. So it's the quickest and easiest way to connect your chain to many other chains. Like I said before, sorry, Axelar is a blockchain for blockchains. So what does that mean? Well, the Axelar chain is itself a chain built on top of the Cosmos SDK. There's currently 75 validators running the proof of stake consensus mechanism. And anyone here in the Cosmos ecosystem that's listening might be familiar with some of these validators, including like Informal Systems, Figment, Pikachu. These are just a few validators that I pulled out to showcase. But it is at the same time permissionless. Anyone can become a validator if they stake enough AXL. Um, Also worth calling out, this diagram is of course, a bit outdated in the sense that Axelar today connects 69 blockchains. We're continually adding more chains. So it's a lot more than just these chains here that you're seeing, largely within the EVM and Cosmos ecosystems, but expanding beyond that very soon. Um, so now we know we have an interoperability protocol that's scalable, that is decentralized and secure. And what can we actually do with it? Why does this matter? Well, a lot of what we're seeing today is the use of asset transfer. And what we've seen over the past few years is the use of what we call gateway tokens. These gateway tokens are kind of like wrapped versions of popular assets predominantly. These are tokens that are manually added by the Interop Labs team to be compatible with Axelar. And it's done a great job of enabling like cross-chain liquidity. It allows like more siloed apps on different chains to use tokens like AXL USDC, AXL ETH, AXL BTC. And this is great and it works, but the goal here is to really empower anyone to be able to build and integrate cross-chain compatible assets beyond the several dozen gateway tokens that are in existence today. And that brings us to where we are today with Interchain Token Service. Interchain Token Service, or ITS as I'll refer to it, allows for cross-chain tokens to permissionlessly be created or integrated by anyone. And I want to unpack this a bit. Permissionlessly. Unlike the gateway tokens, which were onboarded by the Interop Labs team, this can be done by anyone. Anyone can go and create a new cross-chain token or integrate an existing cross-chain token, as opposed to just us. And then I also want to touch on create or integrate. I kind of already mentioned it, but ITS allows you to really do two things here. When push comes to shove, it allows you to create a fresh new, what we call interchain token. These are ERC20 compatible tokens that have cross-chain functionality built into it right out of the box. They're deployed with ITS, so they are naturally integrated with ITS. And they have the ability to send what we call interchain transfers built into the smart contract itself. On the flip side, you can integrate custom tokens. Let me actually flip the slide here. So what I just talked about is the ability to create new interchain tokens via ITS itself, the more like simplified interchain tokens with more limited functionality, which is great for many use cases. Think of like meme coins or something like that. This is super useful for them. On the flip side of creating a new interchain token from ITS itself, is the ability to integrate, or what we call here upgrading an existing token into an interchain token. So what does that mean? These are tokens that are not actually created through ITS. These are tokens that might exist already with like super advanced custom functionality, and you might have that token live on like 3 chains already, and you just want to actually add cross-chain functionality for those tokens. So you can integrate your custom token into ITS, and then that'll allow you to actually send those tokens between the different chains that it's deployed on. So in short, you can create new tokens with ITS or integrate custom tokens with ITS. It's really designed to be as flexible as possible to satisfy as many different use cases as we can. So how is this architected? And this is my super simplified way of thinking about it. There's 3 critical contracts which you're going to have to be interacting with. There's, of course, the ITS contract itself here at number 1. This is a single contract deployed on one blockchain. Well, there's one instance of it deployed on every blockchain that we're all talking to. So let's say I want to deploy a new ITS token on Base, and so do you, and so does your friend. We'll all be talking to that one instance of the ITS token contract on Base, and then it also exists on like Arbitrum, BNB, any of the chains that we can connect. So that's the ITS contract. Then in addition to that, there's the ERC20 token, right? That's the token that we are going to be integrating or deploying, whichever option you take. The final contract is one that I haven't spoken about yet. That is the token manager contract. The token manager contract, you can think of it as like your buddy for your interchain token. It basically facilitates your relationship with your ERC20 and ITS. Unlike the ITS contract, which I said before, there's like one instance of that on a blockchain. Token managers are unique for the token integration. So if I integrate my ERC20 on Base and you integrate your ERC20 on Base, we're going to have different token managers. There's one for each token. And token managers come in different shapes and sizes. There's, I believe, 5 to be exact. I'm going to focus on 2 here. These are the 2 main ones that people typically use are mint and burn and lock and unlock. Just going back to mint and burn here, it really is as the name suggests. It basically will facilitate your relationship with ITS by burning your token on the source chain and minting it on the destination chain. So in this example, let's go through the flow quickly. I have an ERC20 on Ethereum and on Avalanche. I will now call the interchain transfer function on my token. This basically tells the token manager to burn my token on the source chain on Ethereum. Once that's burnt, we send a cross-chain message to the Axelar network. Remember, this is blockchain for blockchain, 75 validators. These validators all come to consensus about the message that was sent. Once they're happy, they will basically forward that message over to the Avalanche blockchain, where our token manager there will mint the token. And so it's simple as that. So interchain transfer on Ethereum, manager burns it, message goes to Axelar. Axelar forwards it to ITS on the destination chain. Our manager then mints the token on ITS. On the other side, there's lock unlock. As the name suggests, instead of burning the token on Ethereum, we actually just lock the token. Then on Avalanche, we mint. And then when we want to send it back from Avalanche to Ethereum, we burn it on Avalanche. And now we can unlock the token, which we had previously locked when we were bridging it out of Avalanche, when we're bridging it back in. The reason we have lock unlock on Ethereum and mint burn on Avalanche is because the way you should think about these different token manager types it's really context dependent. So if you're in a scenario where you have like a token with a home chain, let's say Ethereum is your home chain, you don't want any tokens minted on any other chains. The only liquidity you want existing on, in this case, Avalanche, is in correspondence to a token that is locked on Ethereum. So Ethereum is kind of the home chain in this example. And Avalanche, BNB, Base, all these other chains can be thought of as non-home chains, or satellite chains, I guess, better name. Whereas the previous case, there is no home chain. Let's say you're on Ethereum, you're on Avalanche, you don't care which of these chains is canonical. The token is fluid across all these different chains, as opposed to the other one where there is a home chain. That's kind of the easiest way, in my opinion, to distinguish between whether you want a mint burn manager or a lock unlock manager. We also have, actually, so quick recap of what we talked about, because that was a lot. We have the Interchain Token Service. Remember, that is one contract which exists on each blockchain. It can deploy new Interchain tokens, and it can integrate existing custom tokens right into ITS. In addition to the ITS contract, we have tokens, which use a unique token manager to facilitate that integration. Remember the buddy of your token, the token manager, which is itself a contract. I'm talking about the manager. And managers can take on different types, such as mint burn or lock unlock. That's a kind of high-level recap of what we just talked about. We also have a very easy to use front end. I'm just leaving this QR code here for you guys to scan if you want to take a look. I'll show it off quickly. You can see here it's quite self-explanatory. You have the ability to search for live ERC20 tokens just by pasting in your address and then registering your token that way with ITS. Just a word of caution, this will take the lock unlock approach. So it'll basically say, hey, BNB in this case, which is just what my MetaMask is pointing to, is the home chain. So I'll register it there as the token is written on BNB. And then if I want to deploy it on other chains like Ethereum, it'll deploy like the more simplified interchain token in correspondence to locked tokens on BNB. We also have the ability to deploy new interchain tokens, which I'll step through very quickly right here. Let's see, I want test token, TT. I want to mint like whatever this is, 800,000 tokens. I can call this register button, and then I can select however many chains I want to deploy it on. Then I can continue to follow through this flow. It's as simple as that, really a no-code solution for anyone who wants to deploy new cross-chain tokens or integrate an existing token to go forward here. Leave this QR code for another 5 seconds. The last thing I want to talk about before we get into the more interactive part here is Squid Router. Squid Router is a service that it's a separate team, but they build using Axelar that I want to call out. They're really an amazing service, which allows you, as the image suggests here, to have like cross-chain swaps between assets on different chains. So in this case, we're swapping in one click WETH on Ethereum to BNB on BNB. The reason I'm mentioning this is because what you can see here is the use of predominantly gateway tokens on Squid. But what we also have now, or what Squid is allowed, is the ability to whitelist your token, your token which is integrated to ITS on Squid as well. So if I pop over to the Squid front end, for example, I can look up tokens like any Inu. These are This is an actual live token on Squid. We're on mainnet right now that you can see exists on all these different chains via ITS. So let's say I have any Inu on Ethereum and I want to swap it to an asset on BNB. Let's say, I don't know, let's say USDT. I can swap it just like that in one click, and I can, of course, go both ways. So really an easy way to start gaining traction for users to provide that easy experience of cross-chain functionality for your users by whitelisting on Squid. And we'll provide some info how to do that in the notes here. It's on our docs, of course, as well. And it's a very quick and easy process. I believe that is it for the slides. So let's hop into the more interactive part here. Make this a bit bigger. You see here we have an ITS, a token contract which we wrote up. It's very straightforward. We import on the first line here the Interchain Token Standard. This is made by Axelar, and it basically allows your token to inherit from it, and it very simply allow you to have like cross-chain functionality built into your custom token. So for example, like the interchain transfer function will now be an external function on your token. We of course have the Interchain Token Service contract being imported from here, not inherited, just imported. We have the Open Zeppelin ERC20 contract. Just a little note here that, like, yes, ITS contracts can use Open Zeppelin and it can be as customized as you want it. I really want to drive home that point, that it can handle like any of these vast variety of customized tokens. And then we have our Minter contract being imported here. It's like a little simple like access control style service here. Just scrolling down briefly, it's a very straightforward token. We've taken the name, the symbol, and the constructor, the address of ITS, our salt, which I'll come back to momentarily. A couple getter functions for our ITS address, our interchain token ID, which I'll also come back to. Mint functionality, burn functionality, the ability to add new minters, and then an internal function for an allowance of the token. So very simple token, but a custom token nonetheless, which we will now integrate with ITS. So first things first, let's deploy this guy. Let's do it on Avalanche. I believe I'm on there already, so let's pass in name, whoops, my demo token, MDT, ITS address is this guy. It's the same address on every blockchain it's deployed on. So yeah. And then I'll pass in the salt, which again, I'll come back to in a bit why that matters. The salt, that is. Sweet. So now we have deployed a token on Avalanche. And then let's grab our Interchain Token Service. Is this it? Yeah. Interface. So this is our ITS interface. Let me just scroll down here to the top of the interface. I added it. I'm doing it on Remix. I know, again, it's a bit primitive to do it on here. I think it's kind of just the easiest way to visualize all the different steps. So there's a lot going on here in the ITS interface. I don't expect you to obviously go through it all. The main function we're going to be working with is deploy token manager. This, as the name suggests, deploys a token manager. Remember, what is a token manager? It's that buddy which you have with your token, which facilitates the relationship with ITS. It takes several parameters, deploy it, and once you have your token manager deployed, you're basically integrated with ITS on that blockchain. So let's actually do that. Let's do this first. Cool. Actually, the first thing I'm gonna mint some tokens for myself, because once we integrate, we're gonna want to send some cross-chain tokens. So I'll mint it to me, mint like 50 tokens. Confirm. And while that's going through, let's look at the interface of our ITS contract. And we want to go right to deploy token manager, this function that we're looking at here. First, we're going to need the salt, which I promise will actually be explained soon. Then we have our destination chain. We basically have the ability to send imagine we're on Avalanche now. Imagine I want to deploy this token manager on Ethereum from Avalanche, like do a cross-chain deployment. I have the ability to do that with ITS. I'm not going to do it. I'm actually just going to deploy the token manager on Avalanche, like on the same chain we are, which means there is no destination chain, so I can leave it blank. Token manager type. Remember, there's different types of token managers like mint burn, lock unlock. We're going to go for the mint burn token manager, which corresponds to enum number 4. Our params is this large item here. This basically corresponds to something like ABI.encode operator, token address is basically what I just passed in there. The operator can be thought of as an address with certain roles for the token manager. So like an operator, for example, has the ability to increase or decrease a flow limit. So like if I only want 5 tokens to be bridged in and out of a given blockchain, then the operators who will be allowed is the one who will be allowed to set that address. So I'm passing in the address of my operator and of course my token, which I just deployed in these params. Gas value will be 0 because this is not a cross-chain transaction. And now the salt, I promised I'd come back to that. The salt is used, you can see in the contract here, or the interface on line 267, while generating the interchain token ID. So we use the salt and the operator. Basically, will be the address used essentially deploying the token to generate the interchain token ID. The interchain token ID is how ITS will register your token across all different chains. So recall, we're about to deploy, let me actually run it right now. We're deploying this token on Avalanche. I've already deployed it, I think it was BNB that I deployed on before. And across BNB and Avalanche, how does ITS know who it's bridging between? Well, the token that is deployed, even if the address is different, will have the same interchain token ID according to ITS on both of those chains. So that's how we'll kind of track those tokens. And you generate that interchain token ID with a salt, which we passed in here, as well as with the address of the token that is actually deploying the token manager. That's part of the logic that will be ran when we call this. So it's very important that you don't forget which address you use to actually integrate your token. Otherwise, your interchain token ID will be different and the tokens won't be connected. Now that this is deployed and we have minted the token, let's actually see what's going on here. We called this. We got this transaction hash. Let's go to Snow Trace and throw in this hash. And hopefully we have some event logs here. Okay, Snow Trace is not very happy today. Let's see. Interesting. I don't think this is an issue with the transaction. I think it's an issue from the Explorer side. Yeah. That seems to have been an issue from the Explorer side. I hope. We'll find out in a second if it was an issue with us or not. We see here this interchain token ID that I have, the 0x5A, make this bigger, 5A6. If I go back to Remix and I throw this into this contract, this valid token address, I pass in my interchain token ID. If all went correctly, ITS should return the address of our token. Sweet, it did. 0x260, which I believe is the address of our token. Yes, it is. So it did work correctly. I'm going to throw it in here as well to get the address of our token manager. Remember, the other contract token manager. Oh, here. Token manager, the other contract which matters, is like the buddy for our token, which is unique to our integration here. So we have that address here, 0x0 2D. So now what I want to do is basically add a minter, and that minter will be the token manager, so I can burn and mint tokens as we're bridging the token in and out of the Avalanche blockchain. And I believe I already did this on the other side for BNB. And that's it. Our token is now actually integrated with ITS. So let's actually try send the token. So we're going to send it to Binance. Recipient will be me. The amount, let's just send one token here. Where's balance of that? I want to make sure I have some tokens. Sweet, I do have some tokens. And then metadata will be 0. This is like if I want to send like some extra data along with the token to like have it be executed on the destination chain. Some very powerful stuff you can do with it, but I'm not going to worry about now. Let's just send the actual token. Now we need to send some gas to pay for the cross-chain transaction. We could obviously talk a lot more in depth about how to actually calculate how much gas is needed, but what matters is, and what I'm going to call out here is that even though we're about to send a cross-chain transaction, and let me actually send it, hopefully it works. Yep. Even though we've just sent a cross-chain transaction, paid for it on the Avalanche blockchain, the Axelar network will actually handle paying for the gas cost on the destination chain as well, and on the Axelar blockchain itself, because remember, Axelar is also a blockchain, which is pretty awesome. Transaction hash, let's check it out. Hopefully Snow Trace isn't weird again. Sweet, 23 seconds ago, transaction was sent. and that's it. Our token was basically now burnt. You can see on the source chain. While we wait for it to go through on the destination chain, I'm going to show off another cool feature that we have, and that is the Axelar Scan Block Explorer. The Axelar Scan Block Explorer, I could do a whole other talk about that. It's a real good spot to get like an overview of the entire network, different relevant stats about Axelar. You can see a much more up-to-date graph compared to the one I shared here before of all the different chains which are now actually connected with Axelar. Keep in mind, this is on testnet, not mainnet that we're looking at. But yeah, you can see like all this different interesting stats about Axelar. But back to the matter at hand, I want to take my transaction hash, throw it into the search bar here, and we should see Axelar Scan's view, much more helpful view of the transaction. I didn't send enough of a fee, so I can actually do that straight from the Axelar Scan Explorer. On the topic of gas, we do have like an SDK to properly estimate how much gas you should send. I just kind of sent an arbitrary amount. You can also send a very high gas amount because if you send a surplus, then you'll automatically be refunded whatever gas you've overpaid, which is probably what I just should have done. But this is good to see as well in the case that you do under send gas, then you can top it up from the Explorer or of course programmatically from our SDK. And what's nice about the Axelar Scan Explorer is like, unlike no issues with like any individual block explorer like Snowtrace or Etherscan or anything, the Axelar Scan block explorer is like built to show cross-chain transactions. So you can see like all the details. It's going from Avalanche to the BNB chain. You can see the address of the token, what service we're interacting with, which is Interchain Token Service. You can even see the step-by-step of the transaction being sent. So like I can see I was sent on the Avalanche Explorer. I can click on this, takes me right to the native block explorer, which is pretty neat. I can see the gas being paid. I can see the transaction being confirmed on the Axelar network itself. Remember, Axelar blockchain for blockchains, the 75 validators at this step, at step 3, are coming to consensus about the GMP message that was sent. So if I click on that, we can actually see that on Axelar Scans Explorer. And then hopefully momentarily, we should see step 4 going through, which is basically a transaction, this time on the destination chain, on Binance's chain. And it's basically saying like, hey, this transaction was approved by the Axelar network. And that's what we should see momentarily here on the Binance chain. And then once the transaction has been marked as approved on Binance, we will be able to execute it. And I'm, in the meantime, going to load up our token here on the Avalanche side, hopefully before this all executes. Cool. Where is my balance of function? So you can see 0. So the token has not finished sending yet. This is on, no, remember before it was 50 because that's because we were at Avalanche. Now we're, sorry, we have to be on Binance. I believe that was the destination chain, correct? Yes, Binance. So you could see here that it's executed actually. So now if I flop over my MetaMask to Binance Smart Chain, I throw in this address here, then I can see if I query the balance of, hopefully this should be 1, and it is. We have now successfully, congratulations, bridged our Interchain token from Avalanche to Binance. The reason it was 0 before was because I punched in the address of the Avalanche token, or the Binance token on Avalanche, I believe. But now you can see that it did work. I can go back to the Axelar Scan Explorer. I can see the final 2 steps here, including the gas refunded step that I was talking about before, because I guess we did end up overpaying. So I can click on this, takes me right to the Binance Explorer. I can see my token being minted to me. So this worked. Yeah, that's basically it for this. And for the bounty, I'd be very, very excited to see what kind of token integrations you can do. I'd love to see if you guys can do things like whitelist it to Squid, send data along with your Interchain token. We have full tutorials on our docs on how to integrate this. I'm going to leave this QR code in the meantime. Full tutorials on our docs on how to integrate these tokens. You can, of course, scan this QR code to play around with the front end portal as well. And of course, check out the ITS contract as well. I'll be there for the hackathon, so happy to answer any questions. Thanks very much, and I'm excited to see what incredible stuff you guys build at this hackathon. Thank you.